Let's start with review. Uh, so we have the exam tomorrow. It's Tuesday, covering 1.6 to 1.8, 2.1 to 2.8. Again, make sure same format as last time for the exam. Okay, make sure your webcam is working. So we'll meet and we'll meet here as usual. And you'll turn on your webcam. And I'll email you the exam. All right, you will complete the exam scan with your smartphone and upload to Dropbox, all while on camera. So we have a properly proctored exam environment. Okay. So last time, a couple people kind of left after they were done, then scanned and uploaded. Now scan and upload while you're on camera. So I mean, just so I can, so so we're in a properly proctored environment, and no internet usage. Other than Collaborate Ultra and your phone, and scanning software. All right. Okay. And you can have a simple graphing calculator. Aside from that, as long as the graphing calculator isn't an internet device. Usually they're not, but I suppose there might be some that are. So I just wanna I want to go over questions at this point. We can start going over some of the problems in section 2.8. Actually, why don't we do a few of those first? And then we'll review. But just let's do a couple problems in section 2.8, just so we know, what to expect for handing in this evening. Right. So assignment for 2.8 is due this evening, of course. 40 and 56. So let's do a couple problems like those. So 2.8. So 40. Oh, in number 40, they give you two functions. Um, so let's do like number 40. So number 39, right, which is like number 40. You're given two functions, fx equal to 3x plus 4 and gx equal to x minus 4 plus 3, or x minus 4 divided by 3. Verify that these are inverse functions. That g of x is equal to f inverse of x. So there's a couple ways you can do this. You can find the inverse function of f of x. and just note that, oh yeah, it's the same as g of x. Or you can look at the composition of the two functions and see that it's the identity function. So one way to do this, so check that f following g of x is equal to g following f of x is just x. Right, and then the second way would be to find f inverse of x directly and see that it is the same as g. All right, so let's do the first way. So f composed with g, f following g of x is by definition f of g of x. So that's f of so g of x is x minus 4 over 3. And then f is 3x plus 4. So this is 3, and then instead of x, we've got this expression here, x minus 4 over 3 plus 4. Over 3. So simplifying the expression, the 3's cancel, and you have x minus 4 plus 4, which is just x. All right, and then g following f is g of f of x is g of, and then f is 3x plus 4. Now g is x minus 4 over 3, so instead of x, we have the 3x plus 4. All right, so 3x plus 4 minus 4 is just 3x over 3, which is just x. Okay, so this says that f inverse is equal to g. Is because it does what f inverse is supposed to do. It's the function which you compose with f before and following and preceding, that composes to just the identity function x. Not one, just x. The other way to do it, just find it f inverse directly. So y is equal to 3x plus 4. So switch, remember you switch x and y. X equals 3y plus 4, solve for y. So we subtract 4 from each side, divide each side by 3, and right, this is g of x. All right, this is g of x. Well, this is f inverse of x, and it is the same as g. All right, so for number 40, you can do it one way or the other. The business with function composition, I noticed a lot of folks in section 2.7, I mean, they just weren't real sure how function composition worked. That's like super important, function composition. You're going to have to spend some time, if you're going on in mathematics to, a calculus subject or more statistics subject or something like that, composition of functions must be understood. It's super important. Okay, so the results on the homework for that were not like encouraging for me to see. I understand that sometimes the first time you see something is not always the easiest to understand it, but you got to spend the time to get there. Okay. So if you need a little extra help for tomorrow, you can, email me and we'll see what we can do. Find some time. So that's like number 40. And then the other one was what? It was 34. No, sorry, 56. So 56. So like number 56 would be, say, number 58. So this is like number 56. So you're given that f of x is 4x minus 2 over 3x plus 1. So again, this is this type of function, right? Linear polynomial divided by a linear polynomial. Right, so fx equal to ax plus b over cx plus d, where there's one condition, ad minus bc is not 0, is called a, I think I said Moebius function. It's not a Moebius function. A Moebius function is something else. Something else that you wouldn't see in this sort of track of mathematics. But anyway, close enough. It's actually called the Moebius transformation. So Moebius was actually a pretty famous mathematician. He's got a lot of things with his name on it. This is one of Moebius transformation, and they're an interesting class of functions. And one of the things about them is that they always have inverses. Remember, a function doesn't have an inverse unless it's one-to-one. Or unless you restrict its domain so that it's one-to-one. But Moebius transformation, it's one-to-one over its entire domain. It's always increasing or always decreasing depending on the signs of the coefficients of x. Alrighty, so find f inverse of x. So for these Moebius functions, and this is how you do it. So let y be the function 3x plus 1. Switch. You don't have to switch the x and y, but if you like to, you can. All right, so change the x into y and change the y into x and all the x's into y's, and then solve for y. If you don't switch x into y, then you just solve for x, whatever the case might be, but you're going to have to switch it in the end anyway. Okay, so how you do it, you multiply both sides by the denominator here. Right, and that cancels that out. Cross multiplying, right? One way one can think of that when a fraction is equal to a fraction, you do this cross multiplication trick. So, or just multiply both sides by the denominator. Multiply through here. 3xy plus x equals 4y minus 2. So now you have some terms that have y and some terms that don't. Okay, push all the terms for y to one side and all the terms without y to the other side. So push terms with y to one side without y to the other side. So 3xy minus 4y is equal to minus x minus 2. All right, so I moved the x over here, moved the 4y over there. All right. Right, subtracted x from this side, and subtracted 4y, well, subtracted x and 4y from both sides. And I'm left with this. Factor out a y. Okay, factor out the y. Divide by, the thing that y is multiplied by. And there it is. Okay, so minus x plus, you don't have to write it like that. We'll just write it like this, I guess. So minus x minus 2 over 3x minus 4. All right, so the inverse of a Moebius transformation is a Moebius transformation. All right, and that's how you find it. So with number 58 or 56, it's the same procedure. It's a little bit easier with that one because there's only 3 terms, 1 term on the top rather than 2. So it's actually slightly easier with number 56. What else? For number, say, 67, we have got fx is 5 plus 8x square root. And the graph of this looks like what? So square root of x looks like that. Right, and this one is square root of 8x plus 5. So square root of 8x is going to be stretched. No, compressed. So how's that going to look? Well, this is a square root function shifted to the left. It's not shifted all the way to 5, but it's a square root function shifted to the left. Right, so it looks like that. So find f inverse of x. Now, when you're dealing with square roots and parabolas, quadratic functions, so square roots are inverse functions for quadratic functions. Square roots are 1 to 1. They're always increasing, as you can see, but unless you negate them, which are decreasing. But the original function is not, right? The inverse function is a quadratic parabola, and that's not 1 to 1. Right, so you have to restrict the domain so that it's going to be 1 to 1. Right, so this one looks like that. And what is the relationship between the graph of y equals f of x and y equals f inverse of x? So this is y equals f of x, looks like that. So then y equals f inverse of x is the reflection around this main diagonal y equals x. Okay, so this one's going to go down here, and it's going to come up, and it's going to intersect where the line crosses, so it looks like that. So this is y equals f inverse of x. So whatever that function looks like, the domain is going to be is x bigger than or equal to 0. Right? The domain for f inverse of x. It's going to be like that. So we're going to get a quadratic polynomial, but we're going to make sure that we say, wow, the domain is restricted to all x's that are non-negative. So here we have y is equal to 8x plus 5, so x is equal to 8y plus 5. Square both sides. All right, so I've got x squared minus 5 is 8y, and then divide by 8. All right, so 1/8 x squared minus 5/8 is y. So that's f inverse of x. With domain x bigger than or equal to 0. All right, so with that type of function, then one has to keep that in mind. How about this? This is an important example, and it seems that they don't have it. Oh, they do. They have it in the book. Number 70. Very important example, number 70. So remember the circle of radius 2 centered at the origin. Has equation x squared plus y squared equals 4. Right? One can solve for x and solve for y, but you've always got this, problem of, satisfying the vertical line test. All right, so this is the circle of radius 2 centered at the origin. If we solve for x, or solving for y, we get the following. So y squared is equal to 4 minus x squared. So square root of y squared is equal to square root 4 minus x squared. So absolute y is 4 minus x squared. And let's say that y is positive. Then we get y is equal to 4 minus x squared. And let's restrict the domain to x's between 0 and 2. And we get a function f of x equal to 4 minus x squared, whose graph y equals 4 minus x squared square root is the quarter circle in the first quadrant. So the graph is that. So this is y equals square root 4 minus x squared. Now, if I take the line y equals x, and I flip the graph around that line, what's going to happen? It's not the best picture because it doesn't show what I want to show. There we go, that's better. If I reflect this around the line y equals x, what happens? What do you get?
Same thing.
Same thing. So this function should be its own inverse. Self-inverse, if you will. So notice that the graph is symmetric. Symmetry around the line y equals x. So f inverse of x, should be the same as fx. Let's check algebraically. I mean, geometrically we see, we know it's true. It's a circle, and circles are all kinds of symmetric, right? You take a diameter through the center of the circle, and you flip the circle around that. Of course, it stays the same. But, the algebra should be reflected in the geometry and vice versa. When the algebra is telling you something, the geometry should show it. And when the geometry shows you that something, it should be reflected in the algebra as well. Okay, so let's see that. Let's check this algebraically. Okay, so we've got y is equal to 4 minus x squared. So switch x and y. 4 minus y squared. And now solve for y. So I'm going to square both sides. All right, put the y squared over here, x squared over there. And then take the square root. Knowing that y is positive. All right, so f inverse of x is equal to f of x. So self-inverse function. All right, and that's an important function, this circle function. All right, so those are just a few problems here, and in this section, and really as far as like finding inverse functions of various functions, these are the important ones that come from polynomials and square roots and such. There are some other important inverse functions that aren't algebraic, but we'll cover those later. Logarithms and exponents, exponential functions, those are inverses. And then there's trigonometric functions and inverse trigonometric functions, which are covered in your trigonometry class, not in this one. But the exponential functions and logarithms we'll cover in this class later. All right. So let's start from some review. What kind of questions do you guys have? Specific questions.
For the problems 37 through 48, will they all be each other's inverse?
37 to 48?
Yeah.
Yeah, right. They're just asking you to show that this function is the inverse of that one. But yeah, they actually all are inverses of each other. Yeah. Right.
For number 40, like, I don't know, one of the functions didn't get the other function for when I solved it for y.
When you did the composite. Well, I mean, it may look different, like when you find like you let y equal 2 minus 5x, and then x is 2 minus 5y, solve for y. Um, you might, write it in this form, right? I mean, you might have gotten it in this form. How can I say? Minus 1/5 x plus 2/5. Is that what you got, or something? Or did you get something different entirely?
It's like the difference is a negative sign.
Check it again. I mean, it should work. Let me see. I don't think there's a typo here. Let me check it. So, yeah, it works. Yeah. Double check your work. Try it one more time, and it should work out. If it doesn't, then email me about it, and see what we can do. What else, guys?
Could we go back over something from 2.4?
Yeah. Okay. Which one?
I got 18 wrong.
Okay.
I'm not sure.
So in 18, a function is given to determine the net change and the average rate of change over the given intervals. So this is 2.4, number 18. T to the fourth minus t to the third plus t squared. And we're looking at the interval from minus 2 to 2. So find net change and average change. So g of 2 is equal, so the net change is g of 2 minus g of negative 2. G of 2 is 2 to the fourth minus 2 to the third plus 2 squared minus g of negative 2 is negative 2 to the fourth minus negative 2 to the third plus negative 2 squared. So this is 16 minus 8 plus 4 minus, this is 16. Minus 2 to the third is minus 8. So it's minus 8, but then it's minus 8. So it's again plus 8. And then this minus 2 squared is 4. So these go away, and we're left with minus 16. Right? It becomes minus 8 is minus 16. So there's a lot of negative signs floating around in that, and it's easy to make a sign error. And imagine that may be where you have a mistake. So that's the net change, and then the average change. Net change from negative 2 to 2, and then the average rate of change from negative 2 to 2. So that's g of 2 minus g of negative 2. That's the net change over the length of the interval. So g of 2 minus g g of negative 2 is minus 16. Divided by, this is 2 plus 2 now, is 4. So the average rate of change is negative 4.
Okay, I did get the average rate of change right. I think I just made a mistake on the first part.
Oh, the net change was wrong?
Yeah.
Did you calculate it twice? Because, like, to do the average rate of change, you have to do the net change on the top. Did you use the answer from before, or did you recalculate it up here?
I just used the answer from before.
Which one did you get wrong?
Well, it says I got no points for 18 at all, but I got A incorrect, and then B I did get negative 4.
What's your name? Let me check. Let me double check it.
Phil?
Phil. Yeah. All right, I'll double check it after class. But this is what it is.
I see what I did wrong on the first one, though.
Okay, all right. What else, guys?
The domain and range questions from section 2.1.
What section?
2.1.
2.1, okay. Is there one in particular you want to see, or just anything?
The one I'm stuck on actually is 58, and I would also like some other examples as well.
Okay. So number 58. So 2.1. So x to the fourth all right, now with all of the functions that we're looking at here, okay, the only obstacle to being defined is taking the square root of a negative number or dividing by 0. So for the functions we're dealing with in this section, okay, only two problems can arise. For that prevent a function from being defined. One, division by 0. 2, trying to take the square root of a negative number. So square root, 4th root, 6th root, 8th root of a negative number. You can take the odd root of a negative number, 3rd root, 5th root, 7th root, right? I mean, the 3rd root of minus 8 is minus 2, right? Because minus 2 times minus 2 times minus 2 is equal to minus 8, right? You can take an odd root of a negative number. It's the even roots that are problematic, okay? So that's it. Later on, when we do logarithm functions, there will be another impediment there, but we haven't gotten to that yet. So here, the only thing that could happen that could make things go awry for the function to not be defined would be division by 0. So this is defined, not this, but f of x is defined as long as x squared plus x minus 6 is not 0. So if we factor so if you want x plus 3 and x minus 2 times x minus 2 to not be 0, you need that x plus 3 is not 0 and x minus 2 is not 0. In other words, x is not equal to negative 3 and x is not equal to 2. So the domain is all real numbers x not equal to 2 or minus 3. Number 68. Oh, how about number 66? 66 is a good one. So g of x is equal to x square root x over 2x plus x minus 1, 2x squared plus x minus 1. Find the domain. Okay, well, again, there's two problems that can arise. Trying to take the square root of a negative number or dividing by 0. So in this one, well, already we need x bigger than or equal to 0 in order for square root x to be defined. And we also need 2x squared plus x minus 1 not 0. So solving this, so what do we have here? Minus x plus 1, so x, minus 1 plus 1. Yeah. So this is 2x minus 1 is not 0, and x plus 1 is not 0. So x is not equal to a half, and x is not equal to negative 1. So the domain is all x bigger than or equal to 0, except x, well, and all x bigger than or equal to 0 and not equal to a half. Okay. Of course, this one says not equal to negative 1, but that's not bigger than 0, so you don't have to concern yourself with it beyond that part right there. Number 71. Or number 68. We'll do 68. So x squared minus 2x minus 8. Find the domain. Well, the problem there's no fractions here, so division by 0 is never an issue. So here we just need that the thing under the square root isn't negative. All right, so x squared minus 2x minus 8 needs to be bigger than 0. So this is x minus 4 times x plus 2 bigger than or equal to 0. So Right, testing the intervals for x equal to -3. Now these are both negative, so it's positive. So this is part of the domain, including the -2. For here, in this interval, we try x equal to 0, and you get -8. Well, negative times positive, which is negative. So that's not part of the domain because that's less than 0. And then in this interval here, pick a point to check, and the terms are both positive here. So the product is positive, so this is part of the domain. So the domain is equal to minus infinity to 2, including the 2, union 4 to plus infinity, including the 4. Okay, so that's a good selection of examples for tomorrow. What else, guys? What else?
Maybe something else from 1.7.
Of course, let's see. All right, what do you want to see in 1.7?
One or I guess 42.
42. So we want to solve the inequality 5x squared plus 3x larger than 3x squared plus 2. So with the quadratic inequality, you need to move everything over to the left. So 5x minus 3x squared, 5x squared minus 3x squared is 2x squared, plus 3x, and then bring over -2. So everything is to the left, and we've changed the inequality to have a 0 on one side. Okay, so because you're going to need to factor this and then check where it's positive and where it's negative. So this one, so plus 3, so it's going to be plus 2 minus 1. Right, so this polynomial is equal to 0 when x is equal to positive 1/2 and -2. Right, at x equal to -2, this is equal to 0, and at x equal to positive 1/2, this is equal to 0. So now we have to test these intervals. So pick it up with the interval x equals -3. Excuse me. So for x equal to -3, this is negative, that's negative, so it's negative times negative, which is positive, so that is part of your solution, right, because we want it to be positive. Inside here, x equal to 0, this is negative, that's positive, so the whole thing is negative, so that's not part of the solution. And then something in here, x equal to 1, so this is positive and that's positive. So the product is positive. So that is part of the solution. All right, so the solution is minus infinity to 2 to -2. union positive 1/2 to plus infinity. So that's the solution to that quadratic inequality. There's also, rational functions that have the same kinds of things going on. Take, say, number 70. So solve for x. So 2x minus 1, x minus 3 squared over x minus 4. Less than 0. All right, well, the places where the numerator or the denominator are 0 are at 1/2, positive 1/2, positive 3, and positive 4. So positive 1/2, positive 3, positive 4. And none of those are part of the solution, hence we use open dots, right? Because at those points, either the fraction is 0, which is not less than 0, or it's undefined because the bottom is 0. So none of these 3 points are part of the solution, hence we use open dots. Now check the intervals. So take a number in here, x equal to 0. So this is negative, and then the squared bit is always positive, and then down here is negative. So the whole thing is positive. So that's not part of the solution because we want it to be less than 0. And then a number inside here, x equal to 1. So 2 minus 1 is 1, which is positive. And then the squared bit is positive. And the x minus 4 is negative. So positive times positive over negative is negative. So this is part of the solution because it's less than 0 inside there. Between 3 and 4, 3.5. So x equal to 3.5. So this is positive, that's positive, this is still negative. So it's positive times positive over negative, so the whole thing is negative. So this is part of the solution. And then from 4 onwards, try x equal to 5, positive, positive, and positive. It's positive. So that's not part of the solution. So here's the solution right here. So it's the interval from 1/2 to 3, union the interval from 3 to 4. All right, so the interval from 1/2 to 4, essentially, except for number 3. Okay, so that's a good selection of problems from section 1.7. I'm sorry, guys. Just give me 30 seconds. I'll be right back. All right, what else? What other questions would you like to go over? Anything else to draw your attention to?
A few from 1.6.
1.6. Equations with rational. Oh, that wasn't on the previous exam. Find all real sum. I guess not. Oh. Let's look at 34 was the hand in. Let's look at 33. I thought that was on the last exam. So solve for x. So x over x plus 3 is equal to 2 over, no, wait a minute, 33 I want to do. X over 2x plus 7 minus x plus 1 over x plus 3 is 1. So a least common denominator for all these fractions, if you were to add them together, would be, well, just the product of these two. So your liquid crystal display, or least common denominator, is going to be that. So we multiply both sides by this quantity. So 2x plus 7 times x plus 3 times the whole of x over 2x plus 7 minus, so then on this side you just have 2x plus 7 times x plus 3. Distributing through on this side, 2x, so I have x times 2x plus 7 times x plus 3 minus 2x plus 7 times x plus 3 times x plus 1 . Move that over. Equals, and then on this, well, let me just leave it like that for the time being. Okay, so the least common denominator was just the product of these two denominators, right? Because there's no common factors between the two denominators. If there was a common factor, it's a little bit more sort of involved to find the least common denominator. It's just all the factors together that encompass all of the denominators. So you multiply both sides of the equation by the least common denominator, distribute through here, and now do your cancellations, and all the fractions should disappear. All right, so what will be left here is just a polynomial equation. All right, in this case, a quadratic equation. So you need to set it equal to 0. This one's got a little bit of work involved because we've got to do a lot of multiplication here, but I'll just do it quickly. So this is x squared plus 3x minus, now when you make a product here and you get that minus, make sure you keep it in parentheses, the minus out front. 2x squared plus 7 plus 2, so that's plus 9x plus 7 equals, over here, 2x squared plus 7x plus 6x is 13x plus 21. And now you've got to set all of it equal to 0. Okay? So, what do we have for x squared? I've got x squared minus 2x squared minus 2x squared. So let me actually, it's fine. So I got x squared minus 2x squared, and then this is minus because I'm going to bring it over here. So this is minus 5x squared plus 3x minus 9x minus 13x. So what do we have here? 13 and 9 is 22, so 19. And then for constants, I've got minus 7 minus 21, so it's minus 28 is 0. Let's divide by a negative. This is not. This is more difficult than I would ask on an exam, but So if this better factor, 5x and x, and then the 28, what do we have? 7 and 4. So how are we going to get 19 from 7 and 4? So 20 plus 7 is not going to do it. 35 minus 4.
I think that first number should be negative 3x squared.
So x squared minus 2 minus 2. So it's minus 5. Right? I got x squared minus 2x squared minus another 2x squared. So 28 was, so 14 and 2. So 14 and 2 for 28. That doesn't do it, does it? 14 and 2, no. 28 and 1, no. 7 and 4, 28 and 2. Something went wrong.
I think it's a minus 3x squared.
No, it's minus 5x squared.
X squared minus 4x squared would be minus 3x squared, right?
Oh, that's positive. I'm sorry. Yeah, you're right. Minus 3. So now it should work. So 7 and 4. So plus 7. So 7 and 4, 14 and 2. 21. 12 plus 7. So, alright, so 7 plus 12. And 7x plus 12x is 19x. So we have 3x plus 7 is 0. Or x plus 4 is 0. So this is x equals minus 7/3 or x equals minus 4. Okay. Yes, you're right. That was minus 3. Sorry about that. Okay, so this is a really good selection of problems for the exam tomorrow, okay? But again, mostly the problems are just like the ones we handed in for homework, for the written homework. Not just like, I mean, not the same ones, of course, but things very similar to those. So we've done a nice selection of problems here that reflect that. Okay? If you've got any questions, you can email me. Maybe if we've got some time today, we can meet if you need to. All right, have a good day, everybody, and I'll see you tomorrow.